Day 18.
Okay, so for number 1, if you solve for B, if you solve this for B, you would divide each side by R, and you would get B is equal, oops, what did I just do? Okay, for number 1, if you solve this for B, you would divide each side by R, and the R's would cancel, and you'd get B is equal to P over R. So this here is an equivalent statement. Now, let's go back to the original. P is equal to BR. If you solve this for R, you would start by dividing each side by B. And you would get R is equal to P over B. So R equals P over B. That's not even in there. So A is the only choice. That's an equivalent statement. Okay, so in M is equal to F over A, if we were to solve this for, say, A, we'd start by multiplying each side by A. So we'd have AM is equal to F. Actually, let's look at that. That's solved for F, if we were going to solve this for F. And that's this choice right here, choice D, F equals MA or AM. Okay. Now, if we were to solve this equation here if we were to solve that equation there for A, we would divide each side by M. So I would take this and divide by M, and we would have A is equal to F over M. And that's not a choice. So only letter D is the correct choice. Okay, this problem I'm going to solve for the variable I'm after, which is this little p here. Okay, so I'm going to clear the fractions by cross multiplying. So I have big P, V, little t is equal to little p, little v, big T. All right, and then I'm trying to solve for this variable here, so I want to divide each side by v and by little b, v, and by big T. So little p, I'll write it down over here, little p is equal to big P, big V, little t, all over little v, big T. So now let's start plugging in values. Big P is 50, big V is 9, little t is 350, over little v is 8, and big T is 300. So I would probably just use a calculator to solve this. If you didn't have a calculator, if you didn't have a calculator, you could do something like this. 50 goes into 300 6 times, into this 7 times. 2 goes into 6 3 times, into 50 25 times. 3 goes into 3 once, into 9 3 times. And I don't see anything else that can cancel. So when we multiply across the top, we get 75 times 70. 75 times 7 is 35, 49, 52. This is 525 over 8. And I guess I'm going to use a calculator to reduce that. This is 65.625. Okay, I'm going to solve for L. So the first thing I'm going to do is clear my fraction. I'll multiply each side by L. They cancel over here. So CL, I end up with LC or CL is equal to 100B. And then if I want to solve for L, I can divide each side by C. So I'll get C, or L is equal to 100B over C. So now let's plug in our values. We have 100B, which is 5, over C, which is 80. I would just use a calculator, but if you don't have one, we can divide by 10 on top and bottom, knock that off, and then we can say 4 goes into 8 2 times, and into this 5 times. So when we finally multiply, 5 times 5 is 25 over 2, which is going to be 12.5. Okay, if you need a little step-by-step guide to help you with these, there's 5 steps that will get you through solving any of these types of equations. Step 1 is to clear parentheses. If there aren't, you just skip the steps that you don't need. Step 2 is to clear your fractions. Step 3 is to simplify. In other words, combine like terms or anything else like that. Step 4 is to isolate the variable that you're after. And step 5 is to divide. Okay, so if you do those steps in order, you'll get rid of everything. Now, step 1, there's no parentheses, so we skip it. Step 2, we clear the fractions by multiplying everything by the common denominator of d squared. So that cancels, and we're left with d squared f is equal to g m m. There's no like term, so we skip that. We don't have to isolate because the term that has the variable in it is already isolated. In other words, there's only one term over here on the left. So that means it's already isolated. Step 5 is to divide. So we take what we don't want from this remaining term and divide out the items that we don't want in there. So we don't want the big M or the little m. So then we do that to both sides. So our final answer is G is equal to d squared f over mm. Okay, so here we go. We're gonna, there's no parentheses, so we skip this step. We're gonna clear the fractions by multiplying each of the terms by the LCD. Well, A, B, and C are all denominators, so the LCD is ABC. So we multiply each of the terms by ABC. And we're going to cancel there. We'll cancel there, and we cancel there. So we're left with BC equals AC plus AB. Now we're after A. So we isolate, now there's no fractions. We cannot combine like terms because there aren't any. We isolate the variable that we're after. So the first step in the isolation is make sure the variables that you're solving for are on one side of the equation. Anything that you're not solving for is on the other. And that's the case here. Because the variable is showing up in multiple terms, we factor it out. And we're going to be left with C plus B. That works because if you had distributed this back in, you'd get back to these. Now, step 5 is to divide. We're after the A, so we want to divide out what we don't want. So we're going to divide out C plus B. So we got to do that to both sides. So there was a BC here. We're going to divide out the C plus B. So our final answer is going to be A is equal to BC over C plus B. We cannot cancel anything because remember you can only cancel factors and not terms. And these C's and the B are terms. You could only cancel if there was an entire C plus B factor up here, and there isn't. So we're done. Okay, there's no parentheses, so we skip that step. There are fractions. I'm going to clear the fractions. There's 2 ways to think about clearing the fractions. One way is to, when one fraction equals another fraction, you simply cross multiply. And you're going to get PVT is equal to PVT. The other way to think of it is to multiply by the common denominator, which is TT. And then you cancel, and when you multiply this, you get this side. And you cancel, and when you multiply this side, you get this side over here. So there's either way you think about it, but this will be your next line. So we cleared the fractions. We cannot simplify because there's no like terms. We don't need to isolate because the variable that we're after is already isolated. So we're on divide. We're after this. So we're going to divide each side by little p and big T. And we're going to get little v is equal to big P, big V, little t over little p, big T. Now we cannot cancel anything. Remember, little p and big P are different variables. They're as different as x and y. So don't try to cancel those. Okay, so there's no fractions and parentheses, so we'll skip that step. There are fractions, so we're going to multiply each side by the common denominator, which is r plus nr. We'll do that on this side as well. Okay, on the right-hand side, this cancels, and on the left-hand side, I'm going to distribute that I, and I'll get IR plus INR is equal to NE. Now, that's the fraction. The simplify meaning combining like terms, we can't do that. There's nothing to combine. Isolate. We want to isolate the term that has the variable in it that we're trying to solve for. We're trying to solve for this, so we're isolating this term by moving this term across the equals, and that's going to be a subtraction. So, and remember, you just move a term across the equals, it flips signs because of addition or subtraction. So we'll get NE minus IR on this side. So that's the isolation. Now we're going to divide. We're after this R, so we're going to divide out the things in this term that we don't want. So the I and the N. So R is equal to NE minus IR over IN. And that's all you can do. You cannot cancel anything because there's three terms in this fraction. In order to cancel anywhere, you have to be able to cancel in each of the three, the same thing in each of the three terms. And there's nothing that's common to each of those three terms. So that's a simplified fraction. Okay, so this one we have parentheses. So let's start with that as our first step. We're going to take this stuff and distribute it in. So we're going to get 1/2 h little b plus 1/2 h big B. That's our first step, parentheses. Second step, fraction. We're going to multiply each of these three terms by the common denominator, which is 2. So when I multiply this first term by 2, I simply get 2a. When I multiply the second term by 2, the 2 and the 1/2 cancel, and I'm left with hb. And the same thing happens here. I get hb. Okay, so that's fractions. Step 3 we'll skip because there are no like terms, so we can't simplify anything. Step 4 is to isolate. We're after the term that has the little b. So we're after this term here. So we're going to move this across the equal sign. And remember, that's going to flip its sign. So we have 2a minus h big B is equal to h little b. And finally, step 5 is to divide. We want to get rid of what we don't want in the term. We're after b, so we don't want the h. So we divide by the h. And we're going to be left with b is equal to 2a minus hb all over h. Again, the question is, can you cancel the h from the numerator with the denominator? And the answer is no, because you'd have to cancel from all three terms, and this term does not have an h. So unless you can cancel from every term in a fraction, don't cancel from any of them. But if you can cancel from all of them, you have to cancel. And if you don't, it's unsimplified. Okay, so there's no parentheses, so we skip that. There are fractions, so you can either think of it as cross-multiplying or multiplying everything by the common denominator, which is ER. I'm just going to cross-multiply because we have a single fraction equal to a single fraction. So I'll have ER when I cross-multiply this way. And when I multiply this way, I'm going to distribute, and I'll get ER plus ER. Okay, now I need to isolate. So I need to collect all of those the fractions. We cannot simplify because there are no like terms. We need to isolate. So each of the terms that has an R in it, we need to put on one side. Everything else is on the other. So I need to bring this to the left. And remember, it's going to flip signs when you do that. So the ER minus ER is equal to E big R. Finally, we're ready to divide. We're going to divide each side by what we don't want. We don't want that. Before we can, we're still on isolate because we haven't completely isolated our variable. It's showing up in multiple terms. It's showing up here and here. And it doesn't matter how many terms it shows up in, you simply factor it out. So I'm going to take R as a factor, and I'll be left with E minus little e. Now it's completely isolated. So now I can divide. I'll divide each side by E minus E. And I'll get, I'm going to scroll here a little bit. I'll get R is equal to ER over E minus E. Now the question, can I cancel this E and this E? No, because this term does not have the little e in it. So because I can't cancel from all three of these terms in the fraction, I'm not going to cancel from any of them. And this is a simplified fraction. Okay, so the first step in this that we can do, since there are no parentheses, is to eliminate the fractions. So I'm going to multiply each side by A minus B. Okay, in proportion problems, off on the side, set a little proportion up. We're talking about the number of girls to the total number of students. So I'll set up girls to students. And it says, in a math class, 3 of every 4 students are girls. So I'll put 3 on the top because that represents the number of girls, okay? And 4 students on the bottom. Then I'll make this equal to, it says there are 28 students. So be careful where you put the 28. I put this over here to remind myself that students are going on the bottom. And then we don't know what this is. Now to solve any time you have a single fraction equals a single fraction, you can cross multiply. So 4x is equal to 3 times 28. Now I'm not even going to do that multiplication because I know my next step is to solve by dividing by 4. And if I don't have a calculator, I don't want to multiply just to have to turn around and divide again. So now I'm going to cancel. And I'm going to say 4 goes into 4 once, into 28 7 times. 3 times 7 is 21. So there are 21 girls. But be careful, that's not the answer. The question is, well, that's one of the answers, how many girls? How many boys are there? Well, if there's 28 students and 21 of them are girls, that must mean that there are 7 boys. And that's the whole answer. Okay, so this person can mow 1 yard in 2 hours. So she can do 1 job every 2 hours. What's her rate in jobs per hour? In other words, I want this to be 1 hour instead of 2 hours. So I'm going to divide each side by 2. So this will be 0.5 or a half a job per 1 hour. So her job is 1/2 per hour. Okay, number 27 asks us to solve using a proportion. So a proportion is always one fraction is equal to another fraction. Each fraction represents a situation. So in the first situation, we have 4 inches on a map represents 1238 miles. So I'm going to put inches over miles to make sure I don't accidentally flip-flop this. The first situation is 4.125 inches represents 1238 miles. I set this equal to the second situation, which says that the things are 1606 miles apart. Be careful when you set this up to put the 1606 on the proper side of the fraction, which is why I did this, so I don't accidentally make a mistake. So 1606 goes on the bottom. We don't know the top. This is a proportion, one fraction equals another, so we can cross multiply. So 1238x is equal to 4.125 times 1606. So let's bring this up here. X must be equal to 4.125 times 1606 divided by 1238. And I'm just going to use a calculator for this. So 4.125 times 1606 divided by 1238. And I got 5. It says to round to the nearest tenth. So I got 5.35. Now this is the tenth. So this is going to be 5.4. Now I have to do the correct unit. This is on top of the fraction. So we're putting this in inches. So this is 5.4 inches on the map. Okay, again, we're going to use a proportion to set this up. And we're going to set 2 different situations equal to each other. So the first situation is this many miles represents this many inches on a map. So I'm going to put miles to inches. It doesn't matter which one you put on top and on the bottom as long as you're consistent with both fractions. So I want to make this over here so I don't flip-flop one of the fractions on accident. Okay, so 5619 miles represents 8.5 inches. That's one situation. The other situation is 5045 miles. So when I do this, I have to put this in the appropriate spot. I put miles on top, so this goes on top. And we don't know how many inches this represents. So when I cross multiply, I get 5619x equals 8.5 times 5045. So I'll bring this up here. X is equal to 8.5 times 5045 divided by 5619. And I'm just going to grab a calculator. It's unreasonable to do without a calculator. And I got 7.63. But it's asking, and it goes on, it's asking you to round to the nearest tenth. Well, that's a 3, so that's going to remain the same. So this will be 7.6, and I have to label this. This represented on the bottom of the fraction inches. So this is inches. In other words, this distance here represents 7.6 inches on the map. Okay, we're going to use a proportion again. So the first situation, there's 31 wins and 50 games, regular season games. So I'm going to put wins over total games. And the first situation is 31 wins over 50 games equals. Now, this 162 game, that 162 has to go on the bottom because that's the number of games. And the question is, how many wins would that be? So we cross multiply and we get 50x equals 31 times 162. So x equals 31 times 162 divided by 50. And again, I'm going to grab a calculator. 31 times 162 divided by 50 is 100.44. It asks you to do this to the nearest whole number. Well, this 0.4 does not round up. So this would be 100 wins. Okay, we're going to use a proportion to do this. And the first thing the biologist does is he tags 500 fish. Okay? And he puts them in the lake. Now, assuming nobody's done this before, now of all the fish in the entire lake, 500 of them have been tagged. So I'm going to say F over T. This represents the number of fish and the number of tagged fish. Okay, so in the first situation, we have 500, we don't know how many fish are in the lake. So we just have an X. But 500 of all of those fish have been tagged. That's the first situation. Then later, we go and we collect a smaller sample of fish. We collect 400 fish, 8 of which have been tagged. So when we build this fraction, the number of tagged is 8 out of a total of 400 in that population. So now when I cross multiply, I get 8x is equal to 500 times 400. So x is equal to 500 times 400 divided by 8. So x, I'm just going to use a calculator. 500 times 400 divided by 8, and I get 25,000. This tells me that there's a total of 25,000 fish in the entire, what is this, a lake? Yeah, fish in the lake. Okay, so let's use a proportion to solve this. In one situation, we have 5 gallons of gas goes 156 miles. So I'm going to put gallons over miles. And the first fraction will be 5 over 156. Okay, this I will deal with after the problem. He already has 3 gallons in the car. He wants to know how much more gasoline he needs in order to be able to drive 300 miles. So let's just say this 300 miles I'll put on the bottom of the fraction. Okay? How many total miles could he drive on 300 miles? So I'm going to cross multiply, and I'll get 156x is equal to 5 times 300. So x is equal to 5 times 300 divided by 156. So x is equal to, now I'm going to 5 times 300 divided by 156. I got 9.6 miles. To the nearest tenth, I got 9.6, gallons. But he already had 3 gallons in the tank. The question is, how many more gallons would he need? He needs a total of 9.6 gallons. So let's subtract out the 3 he already has, and he'll need an additional 6.6 gallons. Okay, I'm not sure I like the way the book set this problem up for you, but remember that distance equals rate times time. So if you wanted to find the time, time is equal to distance divided by rate. So this time is going to be 10 divided by 12 plus x, and this one is going to be 6 divided by 12 minus x. And it says that happens in the same amount of time. Well, same is equals. So your equation is going to be 10 over 12 plus x is equal to 6 over 12 minus x. And you have a single fraction equals a single fraction, so I can cross multiply. So when I cross multiply on this side, I'll distribute the 10, and 10 times 12 is 120. 10 times negative x is negative 10x. And then this is equal, I'm going to multiply this way. 6 times 12 is 72. 6 times a positive x is a positive 6x. So I'll bring my x this way by adding it. And 6 plus 10 is 16x. I'll bring my 72 this way by subtracting it. And 120 minus 72 is 28 plus 20 is 48. And then I'm going to divide each side by 16. And I'll get x is equal to 48 divided by 16, which is 3. So the question is, this x represents the speed of the current, and it wants to know, find the rate of the current. So the current is 3, and we're using miles per hour. Okay, number 43, we're talking about rates, times, and distances. So I'm going to make a little chart. Rate times time equals distance. And I have two different scenarios. I have a scenario if you're driving 51 miles per hour and if you're going 60 miles per hour. Okay, so the rate is really easy to fill out. You're just going to put 51 and 60. Okay, it says that if he had been able to go 60, he would have reached his destination 3 hours earlier. So we don't know what this time is, but we do know that if he was traveling 60, the time would have been 3 hours less. Okay? So because this times this is equal to this, we're multiplying this times this is equal to this. We're going to multiply across, and we'll get 51x here, and we'll get 60 times x minus 3 here. Well, this is the same trip, so these distances are equal. So that's our equation. We're going to say 51x is equal to 60 times x minus 3. Or 51x is equal to 60x minus 180. Now I'm going to bring my 51x to the right by subtracting it, and I'll end up with 9x. 60 minus 51 is 9. And then I'm going to bring my 180 to the left, so that'll become a positive 180 here on the left. I'll divide each side by 9, and I'll get x is equal to 20. Well, you have to think about what x is. X is the time, and because this is miles per hour, this represents 20 hours. It's not miles per minute or something like that. It's miles per hour. So that time represents an hour. We need to know x minus 3. That's going to be 17 hours. Well, it says, what's the drive? Oh, actually, that's not what the question's asking. The question's asking for the distance. So we need to find 51x. So we don't really even need this. It's not asking for the different speeds. Okay, so if x is 20, 51x is equal to 20 times 51, which is 1020. You could actually calculate this if you want, but it's the same trip, so you're going to find it's the exact same thing. So this answer is 1,020 miles. And we're using the unit miles because we're after a distance, and we know this is miles per hour. So the answer is going to be in miles. Okay, right off the bat, I can see that this is a rate, time, and distance problem, so I'm going to start with this. Rate times time equals distance. This is a round trip. So I'm talking about a trip there and back. Okay. When I'm going there, we're averaging 200 miles per hour. When we're going back, we're going 300 miles per hour. If the total trip was 4 hours, now what that means is I don't know exactly how much time they took on either portion of the trip, but we do know that both of those things add up to 4. So if you know what two things add up to, but you don't know what they are, choose a variable for one of them and the total minus the variable for the other. Now, no matter what x is, if I add them up my times, it'll always add up to 4. Okay? So I'm multiplying to get across. So this is 200x, and this is going to be 300, 4 minus x. This is a round trip. In other words, we're starting here, we're going here, and we're coming back. We know that these distances are equal in a round trip. So that's the equation. 200x is equal to 300 times 4 minus x. So 200x is equal to, I'll distribute and get 1200 minus 300x. I'll bring my x to the left by adding it, and I have 2 plus 3 is 500 equals 1200. So x equals 1200, divided by 500. I'll knock off a 0. So this is really 12 divided by 5, which I think is going to be 2.4. The question is, how far from San Francisco is it? So we want one of the distances. You can solve for either this one or this one. They're going to be the same because this is a round trip. So solve for the one that looks easier. I'm going to solve for 200x. 200 is 400. I think that's going to be 480, but I'm just going to use a calculator so I don't make a mistake. Okay. So it's going to be 480 miles. Okay, in this problem, again, this is a rate times time equals distance problem. So let's start with that. Rate times time equals distance. And I'm going to make a chart. Okay, now it says there's a first part of a trip and later there's a second part of the trip or the rest of the trip. So I'll do the first part and the second part. Okay, on the first part of the trip, March averaged 60 miles per hour. So let's put in a 60 here. I'm going to put it in a different color. Okay, on the rest of the trip, which was 10 miles longer than the first part. So we don't know what the first part was, but this is x plus 10. It's 10 miles longer. It said she averaged 50 miles per hour. Okay? Now, let's stop right there. Let's use this 30 minutes in the equation. If rate times time is equal to distance, like in other words, if 3 times something equals 24, this must be 24 divided by 3, or in other words, 8. So this is a division. This is going to be x over 60. Now when we multiply, the 60s cancel and we're left with x. So this must be x plus 10 over 50. I hope that makes sense. Okay, so now it said, let's make sense of the equation. It says, find the total distance to Carmel if the second part of the trip took 30 minutes more than the first part. In other words, if the second part was 30 minutes more, that means that if we added 30 minutes to the first part, they're going to be the same. So if we take the first part, x, and we add 30 minutes. Now be careful, don't do this. Because what that means is, since these are in miles per hour, our time unit is in hours. So this 30 would now represent 30 hours. So we need to do 30 minutes, which is a half an hour. So we're adding 30 minutes to the shorter time, oops, this is, by the way, this is the time that we're after. It's x over 60. If we add 30 minutes to that, we're going to get the longer time. So hopefully that makes sense. All right, now I'm going to clear my fractions by multiplying everything by 300. So if I multiply this by 300, this by 300, and this by 300, I'll cancel. 60 goes into 300 5 times, and I'll end up with 5x. 2 goes into 300 150 times, so I'll have plus 150 equals. 50 goes into 300 6 times, I'll distribute that 6 and get 6x plus 60. Now, if I move my 5x over to the right by subtracting it, 6x minus 5x is 1x. And if I move my 60 to the left by subtracting that, 150 minus 60 is 90. So x equals 90. Now the question is, find the total distance. We've only found the distance of, we've only found the distance of one portion of the trip. The other portion of the trip is x plus 10. So x plus 10 is equal to 90 plus 10 is 100. So 100 on the first part, 90 on the second part. The total is 190 miles. Okay, when we read this problem, this is a work rate problem. The work rate formula is work rate times time. Well, let me write to the right so I have some room here. So work rate times time equals work done. Put a line under the multiplication, a line under the equals, and we have Butch and Peggy. Okay, now it says that Butch can do the job in 15 minutes working alone. So if Butch can complete the entire job in 15 minutes, in 1 hour, he can do 1/15 of the job. So that means his work rate is 1/15 job per hour. It says Peggy working alone could do it in 12 minutes. So in 1 minute, she could do 1/12 of the job. So her work rate is 1/12 of a job per minute. It says, how long will it take them if they work together? Well, if they work for X amount of time, it's got to be the same for both of them, and we don't know what it is. They're going to get the job done. So I multiply across to get this, so I have X over 15 over here and X over 12 over here. Now here's the thing. They are trying to complete one job. This is just one room that got messed up. So when I take their amount of work done and I add it together, we're going to get 1. Now, there's lots of ways to solve this, but I'm going to multiply by the common denominator. Well, how about if you can't see what the common denominator is, I think it's 60. In fact, I know it's 60. So I'm going to multiply by 60. By the way, it's not super important that you get the LCD. If you couldn't figure out what the LCD was, you could just take 15 times 12, and that's 180. You could have multiplied everything by 180. You just have a little more reducing in the end to do, but that's not a big deal. Okay. So I'm going to multiply, I'm going to divide, 15 goes into 60 4 times, so I end up with 4x there. 12 goes into 60 5 times, so I end up with 5x. And this is 60 times 1 is 60. So 5 plus 4 is 9x equals 60. So x equals 60 over 9. If I divide everything by 3, I'll get 20 over 3, which is 18 and, 6 2/3 minutes. Okay? If you wanted to, you could say that this was 6 minutes and 40 seconds, but that's probably more than you need to do. So working together, it would take them 6 2/3 minutes to finish the job. Okay, this is another work rate problem. So I'm going to start with work rate times time equals work done. We have two different people working. So I build my chart like that, and then we have Jerry and Kuba. Okay. Now, it says that working alone, Jerry can do the job in 20 hours. So Jerry's work rate is 1/20th of a job per hour. If the two of them work together, they can complete the job in 12 hours. So in other words, they're both going to be working for 12 hours. Okay? We don't know. The question is, how long would it take Kuba to work alone? Well, we don't know the amount of time. So Kuba would take X hours. Therefore, Kuba's rate is 1 over X. So when I multiply across here, I get 12 over 20 and 12 over X. We do know that they're completing one job. So 12 over 20 plus 12 over X is equal to 1. To make my life a little simpler, I'm going to reduce this fraction by dividing by 4, and I'll get 3 over 5. So my LCD is 5x. So here, let's bring this up here. I have 3 over 5 plus 12 over x is equal to 1. I'm going to multiply everything by 5x. That's the common denominator. And I'm going to cancel. 5 goes into 5 once. So here I get 3x. Plus, here we cancel x and x. 5 times 12 is 60. Equals 5x. So now I'll subtract 3x from each side to bring the x over to the right. 5x minus 3x is 2x. And then I'll divide each side by 2. And I'll get x is equal to 30. That means that Kuba would take 30 hours working alone. You can write that in a sentence, but I'm running out of space. So Kuba would take 30 hours working alone. Okay, again, this is a work rate problem. So I'm going to start with my outer part of my thing, which is work rate times time equals work done. I have two different pipes in this system. One is an inlet pipe, and one's an outlet pipe. In other words, the inlet pours water in and the outlet drains water out. Okay. It says the vat of acid can be filled by the inlet in 10 hours. That means that the work rate is 1 over 10. It can fill 1/10 of the vat in 1 hour. It says it can be emptied in 20 hours. So this would be 1 over 20. Now you can put a negative there, but just as long as you understand that an outlet is doing negative work. Okay, how long will it take to fill if they're both open? So together they're the same amount, they're both x. We multiply across and we get x over 10 and x over 20. So our equation, we're trying to fill the vat, meaning we're trying to complete one job. So if we take the inlet work and we subtract, because the outlet is doing negative work, we subtract and get that, we'll get one job. So my common denominator is 20. So I'm going to take each of these and multiply by 20. And This cancels and I get a 2. So I end up with 2x minus. This cancels and I just have a minus x equals multiply and I get 20. 2x minus 1x is 1x equals 20. So it would take them 20 hours working together. Or not really working together, because they're not really working together. 20 hours, how about if I put if both are open?